Thank you for inviting me, Kwanyan. When Kwanyan invited me, I was like, oh, it was like getting invited to a potluck. And I'm like, yeah, I'm there. Then I realized there's a bunch of professional chefs that got invited to this potluck too. And I don't really know how to cook. And so I actually was really nervous. I didn't know what to talk about. So I went kind of meta with this talk. And I hope nobody else brought a meta talk to this potluck. But I want to talk about generative security application engineering. And this is work I'm doing with my student, David Baker Robinson, and my co-PI, Amita Agrawal. So we all know that generative AI is impacting how cybersecurity is being practiced. And what we would like to do is figure out how do we get future engineers to develop reliable, safe, and cost-effective applications. So we built this pilot course. We've been working on this. We piloted it in spring of this year. And so this is the way the course works. We take a week and we have students benchmark a whole bunch of models on a whole bunch of tasks and experiment with prompt strategies. And we saw earlier, how you write your prompts really matters in terms of what you can get out of an LLM. And so most students have no idea. They're just amateur, sort of like, using ChatGPT to do their homework. So we start with that. And then we want them to rapidly prototype LLM applications. And so we introduce LangChain and all of the different features to be able to really create very quickly LLM applications of their own. And then we take them through OWASP's top 10 LLM vulnerabilities, because this is going to be a real problem. We have a bunch of developers deploying all of these LLM applications without a security mindset. And also, I'll talk about why this is a problem. So we want to train these students in at least basic security issues involved with LLM applications. And then finally, we take them through all the different ways that you might apply LLMs to security applications. So code summarization and analysis, reverse engineering, vulnerability discovery and exploitation, command configuration and code generation, threat intelligence, and social engineering. So every week we have a topic, and they're basically using LLMs to try and solve some problem in these topics. And then, so that's in class. And then every week we have them actually write their own LLM application to try and automatically solve one of these things. I want to just talk about the different lessons that we have learned in creating this course and what we have observed in offering this course. So I have 6 lessons learned. The first one, and the biggest one, and the one I'm going to spend the most time on, is that creativity really matters, more so now than in any point in time in computer science, I believe. And so one of the things that LLMs do is it reduces the importance of mechanics. And you've done this in the classroom where you're teaching a lot of the mechanics, like commands, the code, all of these things where you type away to get something done. And if you make a mistake, you have to type away again. And so this is a picture of what my mom had me do when I was a kid. I got 10 cents for filling out 100 numbers sequentially. And we don't do that anymore, right? And then here's another thing. I did this as an undergrad. Like, okay, you can bring as many sheets or 3 sheets of notes to your exam. And I got good at writing really small and regurgitating everything I heard in that lecture. And I don't do that anymore to my students because, well, we have the internet. Like, this is like Google now. Like, this is before Google I was doing this. But yeah, we don't do that anymore. In grad school, this is what I did. I grinded away at the Linux command line because I was like, well, that's how you interact with your computer, right? You have to know basically 30 to 40 commands really well. And so I'm thinking, well, maybe we don't need to do this anymore eventually. And so what do we teach? Like, what are we going to teach these students? So what is the value add of students and humans now that we're doing this? And so my hypothesis is that we just have to focus on creativity and imagination. We have to get kids to practice this over and over again, because that's really the human value add in this day and age, I believe. And so I take inspiration from one of my favorite musical groups. And so this particular group, and I'll be astonished if any of you know this group because they're pretty obscure. Every band member in this group has really broad disciplinary knowledge. They know music inside and out, jazz, country, rock, all of the guitar rock. They're really good disciplinarians. And they practice creativity all the time, even during their performances. It's like unscripted, it's basically creative. And this is a picture from their show in Las Vegas earlier this year. This is in Sphere, which is this huge immersive concert hall. So they're playing music and they're giving you that at the same time. And so does anyone know who this is? I gave this talk to my students yesterday night. And I was like, a sticker to whoever knows who this group is, and one person in the audience knew. Anybody? Okay. And so because this is security, at the end you have to profit. And so this is the picture of the group. Does anybody know who this is? They play in Madison Square Garden, just across the river. They have a New Year's Eve sequence, like 4 shows every New Year's Eve. So this is Fish. And they're one of the greatest improvisational bands on the planet. So I look at this and I'm like, I think that's where we need to get our students in computing. And so that was the question. Like, if I wanted to cultivate this kind of sort of creativity, what kind of course would I build? And that's the big question mark. So the approach for this course is to really cultivate broad disciplinary knowledge. And one of the nice things about LLMs is that you can get students broad disciplinary knowledge because they can ask the LLM a whole bunch of questions and not have you, the professor, be the bottleneck or the TA, right? So that's interesting. That's a nice thing. The other thing that you want to do is, because there are so many different kinds of security practitioners and so many problems that they're trying to automate, you need to expose them to all of the sort of aspects of computer security. And then what you want to do is have them every week practice creating. Imagine and create something every single week, and then really make it intrinsically motivated. So when students pick the thing that they're going to build, they're going to put more effort into actually making it good, rather than me giving them an assignment and saying, hey, do this, and then check off these points of the rubric. They'll just do the bare minimum to get the grade, if that's the case. And so then the question is, do we profit? And I can tell you this, at least intellectually, I personally have profited from this, because every week I get to see just a range of super creative projects that my students have come up with, applying LLMs to some problem in security. And so this is a Japanese proverb that I like to use, because I got more from my students in this quarter that I offered it than any of the other classes that I've ever taught in my career. Okay, so how do we cultivate broad disciplinary knowledge? I'm just going to give you an example of the week when we do command and configuration generation. One of the things that you want to do is, well, that's helpful to do, is to use LLMs to help students learn about some topic. So I'm going to talk about Linux, right? So you can ask the LLM to, ask about what commands to use if you're trying to do a particular task. If you're given a command, if they can summarize in English what that command does, to reproduce that command, because eventually if you're gonna do a natural language interface to the Linux terminal, the students have to learn how to speak the right thing to it in order to generate the command that it wants. And then finally, if you're really adventurous, you would just have an agent apply that command from your natural language to your command line. And this is where, like, do I really need to teach the Linux command line in class anymore? I'm not sure. Maybe in 5 or 10 years, there will be a usable natural language interface to the Linux command line. And I'm like, okay, that saves me time to go on and do something else. Okay, so we apply that to Linux. Then we apply it to G-Cloud commands. So most of the stuff that I offer is on Google Cloud. And you do the G-Cloud commands, and there's like 1,000 G-Cloud commands, and you're like, okay, I don't want to memorize all those either. So then we're like, okay, do the same thing for G-Cloud. Do the same thing for web server configurations. So we like Nginx. It's like, what does this configuration file do? How can I reproduce it? And you go through the same steps to try and get students to figure out what is this doing. IP tables, firewall rules. That's another sort of domain that they might not know anything about that they can do this approach to. Docker container files. So Docker files are a thing to ship software artifacts portably. Kubernetes files, Terraform files, and then finally actual code. So Python, JavaScript, TypeScript, regular expressions. Again, this is all to cultivate this broad disciplinary knowledge in our students very quickly. Okay. And then we apply this to other topics. So when we talk about vulnerability and exploitation and all these other things, you do the same thing every week. And they do this in class, and then they go and build something that demonstrates one of these things in their homeworks. So I'm just going to give you some examples, and these are my favorite examples in the class. So I had a student do a network analyzer, so an LLM agent that basically orchestrates these tools. Netstat to figure out what interface it's on, TCP dump to get the trace, Scapy to parse the trace, IP info to figure out geographic locations of the addresses in the trace, and then send all that to Dolly and say, give me a picture of what my network is doing. So I'm like, oh yeah, that's really cool. I would have never thought of that because I'm old and I don't think about creative things like this. Here's another one, penetration testing. Hey, can I orchestrate these individual pen test tools? And we actually tried to use pen test GPT in the spring, but it didn't work with Gemini. So we were using Gemini at the time. Now, I think we might put pen test GPT in here, but they're doing the similar things. Can I use SQL map, nmap, and this is comics, which is the command injection tool. Can I orchestrate that to basically attack a website? So that was another tool or another application. Here's another one on automatic exploitation. There's a Web Security Academy. So for our web security class, we like using Portswigger's Web Security Academy for assignments. So someone wrote an automatic exploitation agent for this level. And so there's a vulnerable cookie that gets passed in back and forth between the client and the server. And so the student wrote a cookie tool that pulled out all the cookies in the session. And then some of them are encoded in base 64. So ask the LLM if it looks like it's base 64 encoded, base 64 decoded. And then if it looks like the result is a hash, which it is, and then figure out which hash. So use the LLM to figure out the hash ID, perhaps. And then finally, once you know the hash ID, then basically use John the Ripper to do a brute force attack on it. And so then the student had an agent that automatically solved this particular level. I had another student do an SSH honeypot. So with SSH and Paramiko, which is the support for an SSH server, basically ran an LLM to pretend to be a server. And you configure the LLM, pretend to be a Ubuntu 2204 server, and it was okay. But it's definitely creative to be able to do something that looked like this. I had students do basically DNS, TLS, and HTTPS reconnaissance, so tying together these information sources. So the WHOIS DNS information, the certificate transparency log. Mozilla has their observatory, which is basically doing an analysis of all the different security protocols on a particular site. And then OpenCage, which is a geographic IP lookup one similar to IP info. Another week, a student looked at using an agent to basically query fish tank and safe browsing for potential malicious URLs, and then the virus total API to look at malicious URLs and malicious content. So being able to do a natural language interface that it can orchestrate the retrieval across these different services to basically get sort of like a broader view of what particular URLs and binary payloads are. And then another class of tools, and I don't know if Rodrigo's here, but like he does the security, generative security adventures. This was inspired by some of his work where you're basically querying the CG database, the virus total API, the MITRE attack data set. And then I had a student use Red Canary for the sort of attack testing component and had an agent basically orchestrate the use of these particular tools. For one of the weeks, there was a code generation week, and the entire week they were not allowed to manually write a piece of code. So this is like, dude, am I going to have to teach programming anymore? So we use this tool called Aider, which is a chatbot interface to programming. And what they would do is they would basically write the prompt into Aider. Aider would generate the code and do a git commit into their course repository and push it up. And I was like, for that week, you're not allowed to do a manual git commit. Everything has to be done with Aider. And so they got used to developing applications just by natural language, which I think it might be the future. Or maybe the LLM is going to automatically do that part too, but I don't know. And so I had a student do just an OAuth app, with natural language, speaking to the chatbot, generate and commit an application that supports OAuth 2. I had a student using Aider develop a wireless pen testing application where the LLM generated the Python code to orchestrate this air crack ng commands, which is a way of automatically cracking a protected wireless network. I had a student use Aider to do a network packet visualization. So tying together Python Flask for the web UI, the socket package to get the network traffic off of the wire, and then matplotlib to generate these graphs based on what the natural language based on prompting from natural language through the Aider tool. Okay, so that's the creativity aspect of it. Lesson number 2 that I want to talk about is that portability matters. So this is an evolutionary tree of models that some of you might have seen. There are a ton of models out there. And the way I look at it is that these are all tools in a toolbox. You have all these different tasks. You have all these different models that can be used for these tasks. And as a result, you have different kinds of performances across these different tasks. So this is a performance across all these major vendor models on MMLU, math, and human eval. And as a student, you're going to look at this and say, well, which model should I use? And it should be dependent on the task. And so we found through the operation of this class, it's like, if you want to do a code generation task, you want Claude, at least back then. I don't know about now, I don't know, but like it's Claude. If you need large context windows, you definitely need Gemini. If you need reasoning, you need OpenAI, and last week, maybe Strawberry. So we're gonna do Strawberry this quarter, so I'm teaching it this quarter, like the first class was yesterday, actually. And so we'll see if Strawberry, I actually think that this is the right approach for sort of like non-interactive interactions with an LLM where you're just kicking the thing off and running, because you can actually afford to wait 30 seconds on an agent for the LLM to get back to you, just as long as it's more accurate. So, but maybe I'll come back and be able to report out how these exercises went with a reasoning model. If you need an open source, deprecation-free, data privacy preserving solution, well, then you need Meta, Llama 3, Ollama, or Mistral, and then you would be utilizing that. And so this really motivates the use of LangChain. So LangChain is basically, it's kind of a model agnostic framework for building your applications on top of. Now, you don't get to utilize all the fancy newest features that are custom to a particular model, but I argue it's better to be portable than to use to be locked into a particular vendor and have your application only work with that vendor's model. And so this is what I ran in the SAT CPI meeting tutorial. This is you instantiating 3 proprietary models and an Ollama model that you're running on your own virtual machine. And this is what I want to show students. I'm like, hey, this is how you want to build your application so that you can just plug and play the model that you need and test the results. In fact, LangChain makes it super easy to do the comparison. You're like, oh, there's a model laboratory, and I'll just supply all of those models, and then I will send a prompt that says, write me a haiku and compare the results. And this is why I teach LangChain and teach portability, because we live in the age of the cloud where every cloud vendor wants to lock you into their platform. And as an academic, you're like, well, you can't be picking favorites here. And so you have to be model agnostic. And I know most people are just using OpenAI because of its performance, but I still think it's important to be sort of independent of the vendor. Yeah. Okay, lesson number 3 is that skepticism really matters. So I have this plot where you have the objective facts and then you have your beliefs. And your beliefs are sometimes emotionally driven, especially in this day and age, in this climate. And so typically what you see is what you want to see. And then you kind of like, you want the thing to be overlapping, but they're kind of apart. And so I talk about cognitive biases working against us. So I mentioned this thing called an achievement bias. And I just showed you an achievement bias because I showed you all the best projects from my class. I didn't show you all the ones that were like the reality, which is over here on the right. So the stories we tell on social media will make it seem like everyone is achieving this and I suck because I'm not doing that. I'm doing the thing on the right. And I try and tell students that this is what's going on because when you start reading articles or even research papers, you're basically seeing all the wins, right? This survivorship bias. And so all of these different stories, you're like, why doesn't this work for me? It's hiding all the failures underneath. And if you work with LLMs, there are a lot of failures underneath. This stuff doesn't work very reliably. I don't know, maybe your experience is different than mine, but it's like, oh, wow, this is not what I read in the articles for sure. And so when someone says, oh, our model finds and fixes heartbleed in 5 seconds, realize that for everything else, like you had mentioned, probably doesn't work. Most likely doesn't work because it only works, on that particular case because you made it try and work. You spent the time to make it work on that particular case. And so this leads to, this is a preview of OWASP's top 10 LLM vulnerabilities. Number 9 is over-reliance. And so the models are giving you plausible, but sometimes incorrect output. So it's really important that we train future engineers to verify and test the results over and over again. And so I drill it into them. And the reason why they're doing their own projects is because they are n is equal to 1 in terms of their use of that LLM to solve a particular task. And that helps them know to not over-rely on a model. And I think most of the students coming out of there, are a little bit more grounded in reality versus if they're just reading the news releases from these model vendors. Okay, so I'll give them an example of this. Here is a CTF, Natus 12, insecure file upload. And I use this CTF because they have all the source code available. And usually no one goes and patches the source code. So the model hasn't trained on what is an appropriate solution to this. Everyone has write-ups. This is how you break it. But nobody has a write-up on this is the best way of fixing it. And so you're like, okay, ask ChatGPT or Gemini to fix this thing. And the real vulnerability, there are 2 vulnerabilities here. You need to check the file extension of the upload when the person uploads it, and not only that, the content of the upload to make sure it's an image. And so you ask ChatGPT, fix this code, and it gives you garbage. And they have to see that it gave you garbage. It may not give you garbage right now, but I did check. And it's still giving you garbage. Actually, all the models are giving you garbage. And they're not fixing this thing in its entirety. Okay, so lesson number 4 is that change matters. This is what I teach in the cloud class that I talk about. You have to be able to not only learn, you have to unlearn and relearn in the 21st century, because the thing that you learned last year might not be true anymore. And we like to attach ourselves to a narrative. And that narrative, if we're attached to it too strongly, might sort of not do us service when the thing changes. And so I try and teach them the agile mindset, and especially with LLMs, because things are changing so quickly. And so they're not used to that. They see things like conventional medical wisdom changes every 20 years. Like the high carb, low fat diet was with us for decades before we were like, maybe that's not such a good idea. And then it finally shifted. I read an article, I think this is from Eric Brewer. He's like, relevant computing knowledge changes every 5 years. And so I think that's kind of accurate because a lot of the stuff we're teaching now didn't exist 5 years ago. But for LLM capabilities, what is the timeline of, LLMs can and cannot do something? Turns out, I think this is months. Actually, like this course that I'm offering this fall is going to be different than the spring just because they're just different models. And so models get released and deprecated within a year. So here are some examples of that. Gemini 1 and then OpenAI's models, the different models will get updated. And so the thing is shifting all the time underneath you. These applications are basically built on quicksand. So for you to develop a cognitive model on something that only worked at that instant of time is dangerous. Because then you could be trapped in that kind of thinking forever. Well, not forever, but for a while. So then they realized that what didn't work last week might work this week. And what did work, this is worse, what did work last week doesn't work anymore. And I get this, every week they do a screencast for me. And they're like, so many people are like, this worked a couple of days ago. It doesn't work now. I don't know what happened. And that's where they get to understand, yeah, this thing is built on quicksand, basically. And this is an example, right in the middle of the quarter last spring, Gemini 1.5 got released and made for general availability. All my students switched over and they were trying their agent code and it sucked. It was bad. And they all switched back. And they're like, well, what happens when they deprecate 1.0? You're like, oh, well, can I trust 1.5? And this is an example. This is from the Google comparison sheet. They're like, oh yeah, on certain tasks, 1.5 does worse than 1.0. And then you're like, oh, well, that changes. So like everyone is using 1.0 for the reasoning agents just because it worked better for them. And so so this is something we're going to do this quarter. It's like, oh, so that NATIS 12 insecure file upload, did anything change in the model that allowed it to actually do a full fix on this thing? It turns out they're all like, when you say, make sure the file upload is secure, it turns out all the models so far only give you a partial solution. And this is what we're looking for, a secure content type check with MIME content type, and then the file extension being checked. And none of the models so far do this. Okay. The next lesson is that safety matters. And I show this cartoon when I talk about Python deserialization and Python pickles. And so when you talk about models being shipped back and forth as Python pickles, you realize that Python pickles are basically toasters that can turn around and stab you if you unpickle them. And that's what this XKCD cartoon is. It's like, oh, did you read the man page? Because in the Python pickling man page, it says, do not use this and do not unpickle code that you do not trust explicitly. And of course, everyone's just sending this stuff around, not thinking that the Python pickle is going to turn around and stab them in the head, which this cartoon is. And so I think one of the problems and one of the things I want to teach students is that we have the potential of creating some enormous rogue toasters with generative AI and LLM applications. So this is the OWASP top 10 for LLM applications. And I try and teach them all of these different ones. Like some of these I can't teach them because they're more vendor related. But there are, when you're building LLM applications, these are the ones that really matter. And so I have to teach students, you got to be cognizant of this, because if we send out a generation of LLM application engineers who have no knowledge of these things, we're all in trouble. Society is in big trouble. So here's one. And this is a fun one, a fun exercise I run. When Bulbasaur is attacked. So that's a Pokemon that a lot of my students like. We give them an LLM agent that's configured with a vector database and the terminal tool. And you should never use the terminal tool with an agent because that's just way too powerful and too many things can go wrong, but that's another story. We intentionally ask students to leave the terminal tool in their projects so that in the 4th week, they can actually do some of these attacks against the applications that they've run, that they've built the first 2 weeks. And so the agent takes queries from the user and attempts to answer them using React, which is a way of doing the reasoning. And so this is the traditional React template. You give the React template some tools like the terminal and the vector database query. And then this is the typical React sort of sequence: thought, action, action input, and observation. And it'll try and generate the actions, execute them, do the observations. And so this is the structured this is the format of what the model is going to use to generate actions. But what happens if your observation that you're getting back from, for example, the vector database has thoughts and actions in it? And this is what we want students to identify. You're like, oh, that's a problem because this is one flat context that's one big string to the model. And so it can't delineate what came from the vector database and what actually got generated from the LLM. And so now we're stuck because here is a document in the vector database, bulbasaur.txt. It was like, here's some actions that the Bulbasaur can do. And the adversary is like, oh yeah, there's another action the Bulbasaur can do, terminal curl some website. And then you go and you run this agent and you're like, what are Bulbasaur's abilities? It retrieves that document from the vector database and then it executes curl. So it could have done worse. I could have actually done an RM-RF and really give them trauma. But I figured this was severe enough to make them be like, okay, maybe I shouldn't be using the React template as is with a terminal tool attached to my agent. And this is the thing that I think we need to teach students. Otherwise, we're going to get a bunch of toasters stabbing us in the future. The other one I want to teach them is this excessive agency and an insecure plugin tool. So if you go onto LangChain and you're like, oh, natural language interface to SQL, I don't have to have a SQL engineer basically answer queries for my users who don't know SQL. So I'm going to do the SQL database toolkit, and underlying the SQL database toolkit is the SQL database class in LangChain. And as it turns out, these two things are just, well, the one is too overpowering. The SQL database class only accepts SQL strings to execute. And we've known about parameterized queries and prepared statements for a long time, but unless you read the documentation, you don't realize that this is super dangerous. And so if you instantiate this in your program, you're like, look up the hash for Jim, which is what you wanted to answer, and you're like, okay, that's fine. But then if you could say drop the users table, it'll delete the users table. Now, fortunately, this isn't a Git repo, so they can actually pull it back again when they do this. But then they realize, okay, maybe it's not a good idea to actually use the SQL database toolkit straight up. And I think they're finally going to push this out to experimental. The pressure was too great for them to keep this into the LangChain proper packages. But you could do something even sneakier. You could actually say, look up this user and then put a SQL injection in there. And because the underlying SQL database class just takes the query as a string, this works. And then you're in trouble. And so we teach them that they have to use input validation. Because the underlying system is not built in a way that can produce secure agents, you have to use, and this time we use Pydantic, which is a way of doing type checks on the input. We're like, yeah, make sure it's an alphanumeric string. So this is the Pydantic class. Make sure it's alphanumeric. And then when you invoke the tool, the agent invokes the tool, basically it enforces the schema. And then you can use the vulnerable or the insecure sort of regular string that you send the SQL database. Okay, so the last lesson I want to talk about is costs matter. And I live in the Pacific Northwest, and they're like, this is a disaster. When I taught the blockchain course, I got tired of justifying people's use of the blockchain when 90% of the blockchain is sort of criminal activity, and you're trying to teach this topic. You're like, yeah, I don't feel good about teaching this anymore. I'm getting to a similar point with generative AI. It's like, wow, this is a whole bunch of energy cost and not much benefit. And I want to bring this up to the students themselves. They need to think about what are the global implications of everyone pushing everything into generative AI. So this is an article about the US data center energy train wreck. And this is what the cost of percentage sort of difference between a generative AI world versus one that's not. And this is substantial. This actually means a lot to the students in the Northwest. But if it's not just energy, it's at least about money. So these are related because even as a business, when you decide to adopt generative AI, you're adopting that on top of all of the other costs you have to develop your application. So all of these things don't go away. The servers, the databases, the network, CI/CD pipeline, all of these things don't go away, but then you're gonna tack on top of it embedding models, LLMs, and the management of all of this in the generative AI stack. And this makes the LLM queries much less profitable. So on the left is the Google search query and the profit that you can make. And then on the right is an LLM-based search. And you can see we're basically not making money on the LLM search, but costing a whole bunch more per query. The last one is time. So handling mistakes. So because LLMs make mistakes, now you have to have a human double check that work until you're 100% sure that that's actually gonna sort of work. And so in order for them to really understand how they can actually make this situation better, we give them this exercise. So on the left is an assembly, a binary code for a simple CTF level. I run my sort of undergraduate class, my beginning class, like a reverse engineering class. And you basically, if you give that straight up to an LLM, you basically have energy costs and money costs because this is a huge binary, right? And then you have the fact that it doesn't actually solve the level. And that costs you time. And so this is the worst of all worlds. And then what I show them is that, well, if you actually used a tool like Ghidra, and you took that binary blob, which the LLM has really nothing, like it's not trained on binary data. You translate the domain into a smaller, more compact C file, and you give the LLM the C file. Well, the LLM understands C code better than it does assembly, and you can get the thing solved with much less cost and then more accuracy. And this is what I want to show them. When it comes to engineering, you have to think about this. Just don't blindly throw an LLM at it because it's easy. You actually have to solve the problem, and you have to pay the bills. So that's the other thing. Like students get a Google Cloud coupon, and then they're like, Google's paid for all of this stuff. I don't have to care about costs, but somebody's got to pay for it eventually. Okay, I'm gonna skip this because I think I might this is a natural language interface to OpenAPI, and then is this the right way of solving things? And I'll skip that in the order of time to wrap up. So the final lesson, so this is lesson number 7, is I think teaching this matters. I think for the future of the LLM applications that we're going to put out there. And so all of the material that I just went through is available here in these 3 links. And this is the Code Lab site that I use to have students do the labs associated with this. And I guess I'll end here. So thank you for listening. And I got this little quiz. Each one of these animated quiz is one of these 6 topics. So I'll leave that up there for as long as I can, but I take it down now.
Perfect, thank you. You're right on time.
All right.
Maybe